peeps, it's Sophie here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're doing the grade 11 2018 physical science paper, and this is question 4 on Newton's laws. This is about Newton's second law. So let's get into it. It says, learners investigate the relationship between the mass of an object and the acceleration it experiences when a constant net force is applied on the object. They use their results to draw the graph below. So as we can see, this is a straight line graph, and the axis on the x is mass, and on the y we can see it's 1 over the acceleration. Okay, the first question says, state Newton's second law of motion in words. So I've written it in the yellow sticky notes there. It says, when a resultant force acts on an object, the object accelerates in the direction of the force. The acceleration is proportional to the force and inversely proportional to the object's mass. Great. So that's the whole of Newton's second law. It basically says that an object accelerates when a resultant force acts on it, and that acceleration has a relationship with force and mass, which we'll see in this question. So the next question says, calculate the gradient of the graph. So you can use any points, but I'm going to use the point 2.5. Let's just do 2.5 and 0. And that corresponds to 1.25 and 0. So change in y over change in x, that's what your gradient is. So I'm going to say 2.5 minus 0 over 1.25 minus 0. And that is equal to 2. That's our gradient. Okay, so then 4.3 says, hence, so that means you have to somehow use the gradient of the graph, determine the net force applied on the object during the experiment. So before we get into this, we need to know that the resultant force, this is Newton's second law, is equal to the mass times the acceleration on the object. So the mass of the object times the acceleration of the object. Okay, so just keep that in mind for later. So we're going to say that we know what the gradient is, and that is 2. And that is equal to the change in y, which is the change in this 1 over acceleration term, over the change in x, which is the change in mass. And if you just simplify that with maths, you can see that that is 1 over ma. Okay, so we know that ma from up here is equal to the resultant force. So that means that 2 is equal to 1 over the resultant force. So that would mean that the resultant force is equal to 0.5 newtons. So there's 4.3. Great. So then we can write, they ask to write down a conclusion for the experiment. So we can see that there is a constant net force acting on this, and that's kind of crucial to this whole question. So what we can say as a conclusion is that if the net force on an object is constant, and that can be seen by the gradient being constant, the acceleration, or that 1 over a term here, well, acceleration, 1 over a is the term that it's plotted against, is inversely proportional to the mass of an object. And we know that because this is a fraction of acceleration, rather than just acceleration itself. If it were just acceleration, it would look something like that. It would be a bit of a strange relationship that you wouldn't really be able to see nicely. So we know that 1 over a signifies that it's inversely proportional, and there is your mass on the x. So conclusion, net force is constant, so acceleration is inversely proportional to the mass of an object. Great, so that's it for this video. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. You should also be sure to visit our website for more of these epic tutorial videos. And if you can't find the answer to your question, then you can send us the question and we'll respond with a personalized video just for you. But until next time, stay epic.